Hello everyone, welcome back to MindMatrix YouTube channel. So we'll continue the topic which we were already doing. So you have already seen in the last video, we have covered permutation and basic principles like addition and multiplication. Okay, and we have already seen what exactly is a factorial notation. Then if we talk about permutation, we have seen all the four cases within that. Okay, so now I'll be taking the combination part, and then the next one is distribution. So we won't be going too much into the depth, but yeah, still we will be covering basic formulas which are required to understand these. Okay, so let's start with the combination part. So what exactly is the combination? First of all, let me just tell you that. So if I talk about the combination, it simply means selection. It simply means selection. Okay, now what exactly is the selection? That means you are picking up something. Okay, so you had a bunch of things, things were there, and you were required to select something. Okay, you were required to pick some things. Okay, now there will be some kind of what a kind of thinking which will be taking place in your mind, that okay, which one to pick, or which two, three, four, if you have a choice like to take five or six or seven out of consider 10 things. So you'll be thinking, and what if all the things are alike? Let's say, like as in the last session, I already told you about that. That if we have, let's say, 10 chocolates, similar chocolates. So if I tell you that you want to pick five chocolates, would you be thinking anything? The answer is simply no. You won't be thinking much. Why so? Simple reason is because all are alike. All the chocolates are same. You need not to think, okay, this one to pick or that one to pick. Okay, but if you have choices, different type of chocolates are available. In that case, you have to think about that. Okay, that which one to pick, which two, which three, which four to pick. Okay, so there comes the thinking part. So whenever comes your thinking part, there is some counting which is taking place. There is some reasoning going on behind that. If there is no thinking, then the answer for number of ways is always going to be one. So that's it. That is combination selection over here. Okay, so let's say if I have a um, let's say if I have, like, I have already taken the example of chocolates. Okay, so let's talk about something else. Let's talk about the toys. Okay, so let's say you have a younger sibling, maybe a brother or a sister. Okay, and then you are considering, okay, that you need to take some, you have to take some toys. Okay, and there are five different varieties shown to you. Five different varieties shown to you: one, two, three, four, five. Okay, so let's say one is teddy bear, then other is car, other can be like some goggles, other can be some, musical instrument for the kids, and so on. So there are five type of toy which is being shown to you. So you have five choices basically. So if you are told that okay, you need to select some item. Okay, because you'll be thinking, okay, shall I be taking something or not? So there can be like choices with you. Okay, so you'll be thinking, if you have come up with a number in your mind that okay, I need two toys or one toy or three toys, then it's simple directly that okay, it is going to be that out of five, if you want that okay, that I need how many, you need only three. That the formula is simple: 5c3, which is like 5 factorial upon 3 factorial 2 factorial. You must be knowing this. NCR is the formula, which can also be written as C and R, and the other notation for this is this as well. Okay, this is also the other notation, a kind of brackets. In between brackets you have N and N R written there. Okay, so it's like that only. Okay, so how do we get that? Again, it is similar kind of stuff. It is related to the permutation. What do we do in the permutation? If I could have told you, okay, then can you get this answer from the permutation? The answer is simply yes. How? So it would have been like, okay, what would you tell me that I wanted from five toys, three toys arrangement. Initially, you'll be saying, and then at last, when you are having three arrangement, then you'll be telling that I didn't want arrangement, I just wanted toys. So, what could have been done? So, you could have said, okay, that out of five, how I arrange three? In this way. Now, because you had three, now in your hand you're having three toys. So, what is the number of arrangements possible for that? 3 factorial. You didn't want that arrangement, you just want selection. So always remember, permutation is selection plus arrangement. If you want to, avoid that, you'll be dividing by 3 factorial, and that's how you get that as well. If you remember, it is going to be 5p3 is 5 factorial by 2 factorial, and again that same thing. Okay, so I hope that is clear. So the formula is HCR. Now other thing is, this was in my mind when we said that okay, we had a fixed number. Told you that okay, so if you wanted to select all the items, what would be happening in that case? You have 5 different toys and then you wanted all. Do you need to think? No, you'll be simply packing all up. Yes or no? Okay, if you wanted to select R items of that, we have already seen it is going to be NCR. We have seen that. Now before moving to the next, let's just talk about the one further case, one extra case, which is if I say that I don't have a fixed number, okay, I have enough of money, and if I don't like the toy, I won't be buying any toy. Okay, so that can also be the case. So it could be like, okay, I may take 0 toy, 1 toy, 2 toy, 3 toy, 4 toy, or 5 toy. In totality, we had 5 toys. So what would be the total ways in which I can pick these up? So if I talk about not taking anyone, it's like 5C0, and I know for not taking any toy, the choice is 1 only. Don't pick. Okay, what about 1? So it's 5C1, and it is 5 if you see, and that's quite obvious as well. If you have 5 different choices and I need to pick 1, so it's like either this, so it's like 5 choices I had. Okay, 5 for that. And if I talk about 2, it's 5C2. Again, if you want to see that how without combination I can think about that is, you're just looking at 2 combination, okay, without arrangement. So first toy can be any of these 5, second can be one of, after removing the first, what am I left with? So 4 choices, and I'm not talking about the arrangement, I'm talking about just the toys I'm having. Okay, I'm not talking, let's say A toy, B toy was there, so I'm not talking about A, B or B, A. I'm just talking about that I have these A, B toy, that's it. Not first A, then B, or B first, then A, something like that. Okay, so divide by 2. So that's what like we'll be getting over here, 5C2. Okay, that is 10. Again, for this one 5C3, I guess I need not get into the details now. It's like quite clear how do we calculate that. So we'll be summing these up. Okay, summing these up, and what will it be coming up? Okay, it's like a long way, but still we need to understand that because some kind of questions were being asked over here. So if you get this, it is like, it would be something like 5C0 plus 5C1, 5C2. Why we are adding these? Because I will be making only one selection out of these. It won't be like, okay, I'm taking 3 as well and I am taking 5 as well. How is it possible? Either I'll take 3 or I'll take 5. Okay, so only one of these would be happening. So what is this? So in the later slide, I'll be showing you, you must be remembering this binomial theorem, which goes like this: 1 plus x to the power n is nothing but nc0, x to the power 0, nc1, x to the power 1, nc2, x to the power 2, and so on up to nc x to the power n. So if you put x equals 1, so it will be like nc0 plus nc1 plus nc2, and putting n equals 5, you'll get the same. So it's nothing but, if you just put x equals 1 and n equals 5, you'll get the same. So it is 2 to the power 5. And can we get that directly without doing all of these? Yes, we are just learning different ways of solving the problem. How can I do that? So it's like this. You had, again, let me just write 5 different type of toys which were present with you. Okay, so you had a choice every time. Okay, I may take this or may not take this. I may pick this toy or not. Okay, yes, I may take this again or not. May or may not, may or may not, may or may not. So it's like 2 choices for each. I will be taking A or not. It's like 2 choices I'm having. Okay, and how do I get that? You can just get this straight. I'll just show you that as well. So what you'll be getting, why are we multiplying over here? I mentioned over that, okay, we were adding over here and we are multiplying over here. What is the difference? We have already seen in the last session as well. Over here, I had picked up the toys. I had already picked up the toys. 1 toy or 2 toy or 3 toy. So that's how I had a final, final selection with me. So that's why I had plus, because I had to make only one selection out of these. But over here, I have just talked about A's choice, that whether A will be there or not. I have talked about B's choice, whether it will be there or not. For the final selection, I have to consider all, that whether A, B, C, like for each of these, I have to tell that A is there or not, B is there or not, C is there or not. So like this. So I have to consider all. Okay. For all, I need to consider the choices need to be taken or need not to be taken. So that's why we are multiplying it. So again, I'm getting the same answer, 2 to the power 5, which is going to be 32. I hope it is clear. Simple. Taking it up or not taking it up. If I just elaborate it a bit more, just it will take 1 minute more. Okay. So let's say A, B, and let's talk about A, B only, like for the two combinations only, you'll get that. So I'll say pick or not pick. Okay. These are the two choices I'm having, pick or not pick for the B. If you just multiply, you'll get it what I meant over here. If you'll just multiply these, you'll get what I meant over here. So PAPB plus NPA and PB plus NPA PB plus NPA NPB. What does this mean? It concludes everything I've done over here. It means I'm talking about the selection when I have picked up both. This is telling me about the selection when I have not picking A but picking B only. This is okay. Oh, I have written same thing, NPA. So let me just write it NPB and this A. Okay. And this is when I'm picking A only, and this is when I'm picking neither. Okay. So similarly, if I can extend it to 5 elements, you'll get the answer what I meant over there. Okay. So that's how we have used over here kind of binomial theorem, and by using 1 plus x. Okay, there could be A plus B as well, which we'll be looking at and further as just a series or a formula to learn about. Okay, so these were the two cases right now we have discussed. Okay, now let's just talk about further the third case. Okay, so now it is being told what that we are having okay, total number of selection in case we have different or alike objects. Okay, so it is like let me just show you this. So let's suppose I had a teddy bear. Okay, and yeah, with respect to the toys only we are talking about, we have a car. Okay, then we had a kind of let's say what else can be there, some musical instrument. Okay, the same example we are talking about. And the fourth one can be where we have a repetition for that. Okay, it can be something like for the toys, what else can be there, let's say watch. Okay, fancy watch. Okay, and let me just say that these I'm having identical cars. I'm having like 5 cars available with me. Okay, I'm having 5 identical cars available with me, because like the kids these days, they want to just play, and they crash them down altogether. So they like to play, they don't want only one car at a time, they might be needing 2, 3, whatever. Okay, so let's say I'm having 5 car toys, okay, which are identical. Then I'm having 1 teddy bear, 1 musical instrument I'm talking about, and 1 fancy watch I'm having. Okay, so now if I talk about what is the number of ways I can select over here, again, I don't have any budget. Okay, I can buy all, or if I don't like anything, I won't be buying anything over here. Okay, so I have considered both the cases. The different items are there and alike elements are also there. So how would I be picking it up in that case? So see, whenever I'm picking up, always there is a choice that I may take or not take. Okay, so for that, if I talk about this one, so I have a choice over here. I may take this teddy bear or may not take, may or may not, both the cases are there. Okay, so there are 2 choices for this. Okay, I'll talk about the cars later on. Whatever the musical instrument, I have this one musical instrument. So what is the number of ways I can talk about this? Again, two. I may take it or may not take it. Okay, what about the fancy watch? I may take it or not take it. And if I talk about, okay, just to add, you might be thinking, okay, why don't we have another, two musical instrument? So there would be a case that either there will be identical musical instrument or different. And if I talk about a different musical instrument, then it would be coming up over here only. Okay, that it can be like different musical instrument I'm having. Let's say that it was one, it's two. So again, it is a unique one, and that is one only I'm having. Okay, so let's say this was a kind of piano, and this is the kind of flute I'm having. Okay, so different, but if they are alike, then I have to consider it over here only. Okay, and then it would be looking like this car example only, which I'm taking over here. Okay, so I'll just remove this over here. This one I'll just remove. I'm just giving an example how we can deal with that. Okay, so yeah, let me just talk about this further. So we had two choices for teddy bear, two choices for musical instrument, two choices for fancy watch, to take it or not. What about the car? So I have like, let's take like similar example. If you have three different chocolates, sorry, three identical chocolates, what are the choices you are having? To take different number. I'm not talking about if you want to take one, so you can pick any. So there is one way only. But if the number is also not decided whether you need to pick one, two, three, four, then in how many number of ways you can pick these chocolate? The answer is simply going to be either you won't pick any, or you will be picking 1, 2, 3, 4, 5 up to the number of chocolates available. So simply over here, the number of ways of picking up car would be 6. One choice would be to not pick any, zero car, not to pick any car. As we have mentioned for this teddy bear, there was a choice to not to pick any not to pick teddy bear, not to pick musical instrument, not to pick fancy watch. Similarly, not to pick any car, I have a choice. And further, what about how am I getting the 6? So 5 for what does this 5 mean? This 5 means 1 for taking 1, 2 for taking 2 cars, 3 for third, 4, 5, and so on, like till 5. What do I mean by that? Let me just show you over here visually, because most of you might be thinking, okay, how is it working? So the one is not to take any car. Okay, so this is like one choice I'm having. The other is I'm taking only one. So because all of these are same, so that would be counted like one way, one choice. Okay, one choice that I can take any one of these. The other can be picking two, so that again can be any of these, because those are identical. 1, 2, 3 I have just written over here just to just show you that we have 5. Okay, so if I am taking 2 cars, so again it can be like any 2 I can pick up. It can be this. I need not to think because they are identical. So for 2 cars, again I have one choice. If I am going to pick 3, so again I can pick any, so again one choice for that. So that's how I'm getting 1 plus 1 plus 1, 5 over here, and then 1 when I'm not picking. So overall 6. Okay, so 6 choices over here. So if I just multiply, I'll get the answer over here, and the answer is going to be 6 into 8, which is 48. Okay, when we need to pick the toys. Okay, and the number was not fixed, how many I want. If the number is fixed, you can just think about that. You can just create cases based on that. Okay, I hope that must be clear, and you can comment down in the on the video. If you have any doubt, I'll be answering for sure. Okay, need not worry about that. So this is the basic part we are going with. From scratch we are actually building up the concept. We are not going too much into the depth of combinatorics, but yeah, we are building the foundation for a probability chapter over here. So let's talk further. So now we are left with the last case over here, which is like, okay, let's just try this one. No, it won't be good. Okay, so with repetition, so again a good question again. So I'll be picking up another food item example over here. So and I'll be showing you a basic kind of proof that how do we get to the formula, basic proof. We won't be like, deriving it very exhaustively, but yeah, hand wavy proof will be covering. So it's like, okay. So what do you want is, yes. So you want three items. How many items you want? Only three items you want. Okay, let's suppose. And you have kind of five different categories. Five different categories. Categories I'm talking about. Okay, N is 5, R is 3. Different categories I'm talking about. Now, what does this category mean? If I just talk about, so you like within your group of friends may go to some ice cream parlor or something like for eating for anywhere. Okay, so it's like okay, you have already thought that you have like three friends going up. Okay, you have three friends which are like who are going to some cafe, and everybody needs something. What did I mention? Everybody needs something. So it can be the, like, now let me just write the stuff. It can be samosa, it can be a patty. Okay, we have aloo patty. Okay, samosa, patty, or we can have what else we can have. It can be a sandwich, simple sandwich. Okay, and then we have aloo tikki. All of this is very mouth watering. So yeah, but still, it's just an example. Aloo, what did I mention? I forgot. Aloo tikki, yeah, aloo tikki. And how can I forget momos? Okay, so these are the five different categories I'm having. And it's like, okay, any of these can be repeated. It's like, okay, all of the three wants samosa, so there would be three samosa coming up. All of the three wants momos plate only, so three momos plate would be coming up. Okay, and there can be some combination, different combination as well, that okay, one samosa was needed and two aloo tikki, or one patty, one momos plate, and one samosa. So like all of these are like possibilities out there. So the repetition over here means from one category, I can repeat the order. From one category, I can repeat the item. I can have more than one item from the same category, from same type. Okay. So I hope the repetition point over here is clear now. Okay. So now how do I get this? Okay. What is the number of ways I can have this selection over here? So just to get this, we'll just divide it further properly. Like, see, so we have like, okay, three partition. Okay, because we'll be needing three only. It's like very clear over here. Okay, very simple point over here. So what needs to be done? Sorry, not three. We are having five partition. Yeah. So 1, 2, 3, 4, 5. Yeah, five partition I'm having over here. And how many objects do I need? It's like I can say this for samosa. Let me just write samosa. This is for patty. This is for sandwich. Okay, this was for samosa, patty, sandwich, aloo tikki, and this was for momos. Okay, these are different bins I'm creating over here. Okay, now if I talk about that how will the selection be taking place, it would be something like this. It can be like 3 0 0 0 0, or it can be like 1 0 1 1 over here. And this is like just the partition line, and 1 and 0, three items done. Or it can be like, okay, 2 over here, 1 over here, and then 0 for all. I hope you have got the idea that okay, from any of the category, I may not be having any of the items selected. Okay, so how do I select, how do I solve this problem now? I hope the overall idea is clear right now, that how am I proceeding with the selection part over here. Okay, so let's now just come to the fun part, how we will be solving it. So just as a kind of proof as well over here, we'll be considering the selection part. Basically, we'll be using these partition line as an example which will be telling me, okay, which quantity I'm going to pick. What I mean by this is I'm having this 1, 2, 3, 4. So these are 4 partition line. I'm having 5 categories. To divide 5 categories, I need 4 partition line. I hope that is clear. Okay, so there will be n minus 1 partition lines. It is important. Partition line. Okay, and now I just need what? Either 3 needs to be filled up over here, and then nothing must be available at any other category, or 1 over here, 1 over here, 1 over here, and rest must be blank, or 2 over here. So I may say something like, okay, I'm filling zeros. Okay, what I mean by this is, if I have put 0 over here, 0 over here, and 0 over here, it means I've taken one samosa, because just before first partition line there was samosa. Within first 2 partition line it was patty, so I'm not taking any because there is no 0. Between second and third there are 2 zeros, which is representing what? Sandwich. So I'm taking 2 sandwich. After this partition line there is nothing, that means I'm not taking, nobody's taking any aloo tikki. And after the last partition line there is nothing, that means nobody's taking momos. Okay, I hope this clears the basic idea. So if I am writing something like this, so what does it show over here? I haven't put any 0. So yeah, what it is telling me that I'm taking 2 plate of momos and 1 plate of patty. Okay, so now you can just think about this, that how it is analogous to creating a binary string with how many zeros? With r number of zeros. Zeros is r, which is telling you exactly selection you need. How many selection you need? Okay, and what is this one? One is number of partition line, n minus 1. Okay, which is like partition line. And how do you get this partition line? You know already, n was your different category, so out of that you just need to pick what, n minus 1 is going to be the partition line. So what is the number of ways the selection will be taking place? You just need to create the binary strings possible over here. Okay, so it is like simply analogous to that. So what is the final answer you will be getting over here? So it would be, you have 3 of zeros and 4 of these. So it's like 3 plus 4, 7 factorial upon what? 3 factorial and 4 factorial, because 3 zeros are alike and 4 ones are alike. It is just similar to that. So if I just write it up, it will be coming like, just explain, the expanded formula would be something like this: n plus r minus 1 c n minus 1. Okay, where n represents what? N represents your number of categories which can be repeated, and r represents number of selection, which can further be written as n plus r minus 1 cr. Okay, so this n or r can be changed as per the assumption we take, that whether we are calling n as the number of selection or r as the number of selection, and the notation changes for the other variable r. Okay, the formula is n plus r minus 1 cn minus 1. Okay, and we have already discussed that how we have got this formula as well. Okay, so why this n plus r minus 1? Because it was like n minus 1 partition line plus r. So overall we had n plus r minus 1 total binary symbols, and then if I just do this, if you just expand it, you will get the similar kind of expression. So that's how we get this. I hope this part is also clear. When we have repetition, we can do it like this. So all in all, not going into the detail of ones and zeros. It was just to show you an example that how does it work, how can you derive it. Okay, so next time if somebody is asking you that okay, let's suppose again, what kind of stuff can be there? Repetition. Okay, so you have so I'll be coming up with the same thing again. So it's like 8 different chocolate types are there, and you want 5 chocolates. You want exactly 5 chocolates. So the answer is going to be very simple. It is 8 plus 5 minus 1 and C 8 minus 1. Okay, that is going to be a final answer over there. I hope it is clear. So now we will be moving further. So these were the common questions and concept around the combination, the selection part. Okay, So next I'll be covering the distribution part. Okay. So yeah, now the distribution. In the next video, I'll be covering up some questions. Okay, those are the previous year questions, which will be covering questions from all these concepts we have seen. Okay, so all in all, it was like nearly 1.5 hours of lecture, which I have broken into different videos, 3 videos nearly, so that you may also not feel like okay, it's like too long or covering all together. So that's why if needed break, you can just watch one and then later on another. Okay. So let's just start with this thing now. So what is this distribution and bin and ball stuff? So bin and ball is like the overall general term which we use over here. So it's like you have some bins, and you have got some balls, okay, which you need to put in these, bins. So this is like you're kind of distributing these balls among these bins, okay. And just analogous to this, we can have a number of other examples as well, that okay, instead of bins there can be people, okay, whom we are distributing something, okay. It can be a kind of what kind of some sweets, or some kind of what else can be distributed to them. It can be some gift items we are giving them, okay, and something like that, okay. And similar to that, or something like okay, there are some candidates which are being getting some posting in some different locations. So in that case, those location will become bins, because and those location they'll be distributed at different locations, okay. So that is how the distribution kind of problems comes up over here, and we'll be seeing those examples as well, okay. So if I talk about the distinct bins and distinct balls, this simply means the balls are also different and bins are also different. So what would be happening in that case? So it's like simple, okay. What we will be doing over there. So for an example, let's say you have you know 30 cards. What's it? So let's suppose you have some kind of cards. If you remember in your childhood, there were Pokemon cards, okay. So you have 30 Pokemon cards, okay, and you need to distribute it among 3 friends, okay, with something like 4 each, okay. You want to distribute 4 to each, 4 cards to each, and there are 3 friends, and you want to distribute 4 cards to each, okay. So now what is it like 4 cards to each? What will be the number of ways in which this distribution can take place? It's like simple. Out of 30, you'll select 4 cards first. Now simply those cards would be going to first friend. Now how many number of cards are left? I'm left with 26. So out of 26, again I'll be picking up 4, and those will be distributed to the next one. Let's say B. And now what I'm left with? 22. So now I'll be distributing again 4. So that is going to C. Okay. And now rest of the cards, which are like 18 cards, I'm not using. What I said? 18 cards I'm not using. So I have distributed overall 12 cards. So you might be thinking that okay, so selection is done. Selection is being done over here. Okay. What about the arrangement? That 4 cards coming over here, so those can come over here, this can go over there. You might think that like that, but when I'm selecting and just moving on further after selection, that is by default arranging as well. How it is taking place? Let's suppose if I say that with this selection I had C1, C3, C7, let's say 12, and with this selection I had something like this: C4, C8, C6, C7, something like this, okay. So you might be thinking that this must also go to this one, and this must also go to this one. There must be a kind of arrangement as well, but that is by default taken care of by this formula, because when I talk about 30 C4, then it will be consisting of all the four combinations possible. So that will also be including this combination. And when this combination will be included over here, then that for sure these cards are left. So for the rest of them, one of the four card combination would be covered over here, which will be like this only. So that arrangement is by default also covered. So what do we get? This is the final answer we get over here. And we have 30 cards and we need to distribute 4 cards to each of our 3 friends. So we have 30 factorial. So if I just open it up, it would be something like this. 30 factorial upon, what is this? 26 factorial into 4 factorial. The next one would be 26 factorial upon 22 factorial 4 factorial, and then further 22 factorial upon 18 factorial 4 factorial. So if you just look at this carefully, you'll see some cancellation part would be there, and overall it will be like 30 factorial upon 4 factorial cube and then 18 factorial. Okay, I hope it is clear. So it is similar to that stuff as well. When we are just arranging 30 cards, it is just similar to that, if you can see it clearly. Okay, just to give you let me just give you a hint over here that how you can think about this. If you have A, B, C, these were 3 friends. So let's suppose the 4th one is not a friend but just an empty box I'm talking about. Okay, empty box I'm talking about. Okay, so I have to put all of these cards, such that each of these must be having this must be having 4, 4, 4, and the rest of these must be coming over here. So how you can think about this? Okay, so it is nothing but arrangement of 30 cards, and then no arrangement among no arrangement among these, because it is all about the combination we are talking about, selection we are talking about. We're not talking about, okay, that I have C7 card first and then C3. It is just the combination. We are just rest assured with that. We are not talking about which card I got first. Okay, so no arrangement over here. Again, no arrangement taking place over here, and no arrangement is considered over here. So it's like if I just arrange all the 30 and then I consider all of them alike, that means their order won't matter. And then again for these, no order is being sorry, we won't be considering the order over there. Again, same for this and same for this, we'll be getting the same answer. 30 factorial upon 4 factorial, 4 factorial, 4 factorial, and 18 factorial. That's how also we get the same answer. I hope this idea is clear of how do we get this. Okay, and similarly we can derive the expression for that how we get this. Okay, so let's talk about the next example we are having. Next is, if I'm having distinct bins and identical balls. So now this is similar to the combination with repetition formula we have seen. Okay, just remember, I am just reminding you again that N and R may change as per your assumption what you are taking. Okay, so you'll be getting the same formula over here. Now let's just talk about this. It is similar. I'll just show you this, that how is it similar. So x1 plus x2 plus x3 equals 14. Okay, let's suppose this. Or what I could have said is that, okay, in total, let's suppose yeah, the toy example we can take. Okay, toy example. Yes. So in total I need 14 toys. What did I tell you? In total I need 14 toys, and there are different categories which is being shown to me, that okay, I have like teddy bear. I can repeat any of the teddy bear, like I can repeat, I may not be taking any, or I can repeat 3, 4, 5, all of them I'm taking as like 14 teddy bears I'm picking up. And then I'm having kind of a Barbie doll, maybe for the boys. They may not be, it may not be a good choice to take, but still, just for an example. And this can be a kind of musical instrument again. Okay, so just think about this. These are 2 identical problems. We have already solved this kind of thing. Okay, we have already solved this kind of thing. And this problem becomes similar to this. Okay, so what I'm talking about now is that you need to distribute something which is identical to three different bins. It can be like you are having 14 laddus as an example. You are having 14 laddus and there are three different people in front of you. Three different people in front of you. So in what number of ways you can distribute these 14 laddus to these three people? So it can be like, okay, you know the idea. It can be like 0 0 14, all 14 to 1, or it can be like 2 2 and then like 10. So something like would be happening. Okay, and an identical example I have created where it is similar to the combination with repetition example. Okay, it is similar to your combination with repetition example. So now over here what it has become like, so it's like you are having 14 selections. 14 selections you are having. Okay, and again you are having three different categories. What did I say? Three different categories. So now I'm creating an analogy among this distinct bins and identical balls and combination with the repetition case. So let me just write a small analogy over here. If I talk about distribution for this case only, distinct bin and identical ball for distribution, and when I talk about combination, that too with repetition, combination with repetition. So okay, what is my n, what is my r? So if I'm talking about my n over here, okay, so n maybe like, so just just to keep these things common over here. So n, what was the n when I talked about combination with repetition? So over there my n was categories I was having, which I could repeat, categories. Okay, and r was the selection I wanted. So if I just create an analogy over here, so over here in the distribution part, R becomes my number of balls or item I need to distribute, and N becomes my bin box in which I'm distributing it. So the formula remains same, that is N plus R minus 1 C N minus 1. Okay, that is going to be the same formula, and you just put it, you get the answer. So the answer is going to be 14 plus 3 17 minus 1 16 C2 is your final answer. Okay, for this one 16 C2 is going to be your answer. Okay, I hope the idea is clear how do we get this. And the next two part are very simple, you need not to think much about that. I'll be just giving you a small example where you will be understanding it clearly. Okay, so let's move next. Okay. So let's talk about this case, identical bins and distinct balls. So now I'm having identical bins. It's like now if I talk about, so just to take an example, I'm having, let's suppose, what do I have? I'm having 6 books, all different books, and I'm having 4 bins. Okay, it would be a complex problem to solve. Okay, but I'll give you the example because I'll then decrease the numbers and then we can get the answer. Okay, exactly. Okay, so the thing is, I'm saying I'm having 6 different books and I'm saying that 4 identical bins are there. Now what would be the difference over here with respect to this and this? This is quite different, this we can always identify. Okay, but how these cases would be different, I'll just show you over here. Okay, the first and third case. So just for an example, let me just no, reduce these values because you won't be getting that higher number values for sure. Let me just reduce this value to 4 and 3. I hope 4 and 3 would be fine. 4 and 3. Okay, So what would be happening? So it's like again a kind of the bins are like this only, 1 2 3. So bins, these are the bins I'm talking about. Mm, just erase. This is the B2 bin and this is B3 bin. Okay. So if they were distinct, so it would have been like this. Okay, that okay, I'm having, okay, I need to distribute 4. So either it could be like 4 0 0, all the 4 are going in same. It could be like 3 1 1 or like 1 3 1. Sorry, not 1 3 1 0 0. It must be 0 0. So either 0 over here or 0 over here, because we have only 4 books, or it could be like 2 2 0, something like this. And same would be happening, like the division would be taking place, the division which will be taking place would be same for both the cases. Okay, the B, because we have 3 bins, so as I mentioned, B1 B2 B3, and with respect to the books I would be distributing like this. The only difference would be, see over here, this is B1 B2 B3. I am able to identify that these boxes are different, but when I'll be talking about this case, in that case this B1 and B2 and B3 are like same, I can't identify. So it's like, see the example over here for B1, here this case, for these two cases, are different for the first part, distinct bins and balls, because over here I was putting 3 books in B1, and in the second one I was putting 3 books in bin 2. But if I talk about the bins are same, then in that case these two are same, because if I have put 3 books in one of the boxes, then it can be any of these boxes because all are same. It's like same case. So over there these two cases becomes identical. I hope the difference is clear. So we won't be counting as different cases over here for the third case. Okay. So I hope the example is clear over here. So what would be the number of ways you can do that? So it would be simply, the answer would be something like this: 4 0 0 you can do, or you can do as 3 1 0, or it would be like 2 2 0, 2 1 1. What else can be there? I guess it's done or not. I had only 4 books now, so I guess these are the only cases. If you find, because this is an hypothetical example over here, if you find some more cases, just find out that, and the answer is going to be, it's like, because I'm selecting 4 books, I had 4 books, out of 4 I need to select 4 books only, so it's like 4C4. So this is counted as one way for this one. Now these 3 boxes, see the difference over here. These 3 books are different, all the 4 books were different, so there can be a combination of these 3 books. As for an example, ABC, there are 3 books, 4 books, ABCD. So the combination of 3 can be ABC, ABD, BCD, ACD, something like this. So there are number of different combinations available. So for this I'll be having 4C 3 ways, and 1 book is left, so that can go to any one of the box. So there is no point in thinking about that in which box I must be putting this book. So 4C3 again, 4C3 how? Because I need to pick any 3 books, and there is thinking you have to do, out of 4 which 3 to pick, or which one to lose, which one to just not to take, which one not to take. So it's like 4C3 or 4C1, like with respect to the same thing. And if I'm left with 1, so I need not to think further for this case of identical bins, because 2 bins are same, so I can put it over here or over here. There is no thinking going on. So for this one it's 4C3, for this one again it's going to be 4C2 for this one. And just because I'm left with 2 books which would be going to 1 box, any of these, so again I won't be thinking about which 2 books would be there, because when I have taken 2, so rest of the 2 books would be going to only single box, which can be either this one or that, and those are identical. I need not to think much. Now for this one again 4C2 again, now I'm left with how many books? 2 books are left. Now I know again I'll be splitting it into different ones, because in each of the box I have to put one. So again, do I need to think? Because the boxes are identical, I won't be thinking I can put it like this or I can put it like this, but still the arrangement or the simple distribution for those two books are going to remain same because the boxes were identical. So you just add these up and you'll get the final answer. So 4C2 is like is 6, uh, yeah, 6 plus 6, 12, 12 plus 4, 17, and 1 is 18. 18 is the answer for this. If I have not missed any combination over here, okay. And if it would have been okay, what did I say? That all these bins would have been different, then I would have, just multiplied with the arrangements as well. Okay, I could have considered, okay, that they could go to some others as well, like 400, 040, 004. That would have, that also I would have taken as a case. For 310, I could have taken another case like 013 or 031, something like that. I hope that is clear. So all those cases must have repeated in that case if I was considering this first case over here. I hope it is clear, a simple example. Okay, now we are left with the last one. So it's like most simple one. Okay, what happens in this case is you just need to partition. So if R is the number of, what do I say, what we said over there was was the selection of things I need to select. Oh, okay. So R were, I guess, the balls. So if I have R balls and N bins, okay. So it's like you have to partition number R, partition integer R into at most N numbers. So if you remember the last case only, okay, where we had like 4 books and all the books are identical now, okay, and I had 3 boxes which are also identical. So what would be the answer for that over here when I have like bins and balls all are same? So it is going to be, so I have, what I wrote was 400, 310, 220, 211. This was the case. So see, I won't be talking about the combination of books over here because books are also same. All the books are same. So I won't be talking about, okay, that from 4 which 3 to pick, from 4 which 2 to pick, because all are same. So there would not be any kind of combination. There would not be any kind of arrangement that 040 or 004 must be there. Okay. I mean, I'm talking about the bins position. Okay, that B1 is having 4, so might be B3 is having 4 if distinct bins were there, but because all the bins are same, so we are not having that those arrangements as well. Okay, so what is the answer? The answer is simply the number of ways I have broken 4 into maximum 3 parts. 4 into maximum 3 parts. So there are, I have decomposed my number 4 into 3 parts, and the number of ways in which I can do that is going to be my final answer. So over here 4 is the answer. 1, 2, 3, 4. 4 ways in which I have broken. Okay, so that was about the last case of the distribution, identical bin and balls. That is clear. It's really a great kind of like a great concept. I really love it while teaching. I really teach it like with more examples, but yeah, over here it's not needed if you can get these, because you won't be really getting these kind of questions. You'll be getting something simpler, and then on the basis of that you'll be calculating some probabilities. Okay. So this was the distribution, and at last these are some of the useful identities which will be very useful for you guys. So it's like you must be already knowing the GP you're having, geometric progression. You must be knowing this formula. Okay, this is when R is less than 1. Okay, basically R is something like this. Okay. Okay, so I guess we need to cancel this up. Okay, yeah. So I guess these are the identities, and you won't be, if there is any difficulty, I can cover up that in our next lecture. So bye bye guys, thank you. And it's like electricity fault right now. Bye guys, thank you.